Welcome to Weathered Questions, where we answer the questions on your radar.
Well, hello and welcome into Weathered Questions, podcast where we answer the meteorology questions on your radar. You can send in your questions to weatheredquestions@gmail.com to join in on the conversation with myself, meteorologist Jan Kaj, and Kai O'Mara. We are so glad that you're with us here again, wrapping up season 5 today as we are just about to head into September. It's crazy. School's back.
Love it.
We are just moving right on through the year. This year is flying by. I feel like we are constantly saying that, but it really truly is.
Yep.
So,
well, I was talking to the neighbors last week and all about this, and I said, I loved summer as a kid, and as a parent, summer is very challenging because all the routines get broken. Nights are way too late. Mornings are way too late. We have various vacations that come through, very small trips that happen. Sometimes family comes in. It's like, all right, I'm kind of getting ready to go back to business here. So I'm all for it. This is a great week for me. Let's put it that way. This is a terrific week for me.
I thrive on a schedule. And
I know you do.
Even without kids, right? Like summer is just insane. So
and you thrive on organizing.
I do.
I laugh sometimes when I see some corporate spreadsheets and I go, oh my gosh, Jan would destroy that.
They need a Jan.
They need to hire Jan. Yeah. Yep. I know it.
Well, let's dive into our first question for the day. This one's a little broad and something that I think Kai and I will probably be able to talk about for quite some time. So we'll see how long we go with this one. But the question is very simple. Why do forecasts change so quickly sometimes?
I think it depends on what we're trying to forecast.
Yeah.
It depends on the pattern in place. And I know where this could go. I know that this could be one of those situations where you're starting off a school day with either a slight chance for a thunderstorm and you get a huge line by the afternoon, or it's the opposite. And there's actually a significant amount. I remember this. And I still get messages sometimes about this, though I don't really have to respond to them. I usually do because I know the people that are asking, but there's a tremendous amount of interest in weather and athletic events.
Oh, yeah.
Especially with high schools and especially with football season, because those guys have been practicing for a little bit now and they're getting ready for week 0, I guess, in the scoreboard, but whatever it happens to be. Those games are important and they happen in prime time of lines of storms to come through. And so if there ever are slight chances that turn into something large, that can be a big deal. I think it just depends on what we're forecasting. If there's a high pressure system nearby, the chances of that forecast changing are very small. And let's just say I'm not going to count 2 or 3 degrees. I'm going to say that's a hit. Okay. If it's 75 and it becomes 77, I don't think anyone cares.
I think that's still a win.
That's still a win. That's very much still a win. In fact, the average error of an airport, I think, is a degree or 2 anyway. So whatever, not a big deal. The biggest problem comes in when we're trying to figure out, and this could even happen, Jan, 3 days in advance.
Absolutely.
If there's a huge Arctic front that we're tracking, we know we're going to get smoked by it. What time is it going to happen? Because we're going to go from highs in the 30s and 40s to highs around 0. Let's just say that's what's coming. And school districts are trying to figure out, because there's going to be a ton of wind. It's like, oh my gosh, it's going to get cold. But when's it going to happen? That, has some high stakes to it. And so I think you got to take a middle of the road approach on that. But that's an example of how a forecast could change rather quickly. It might shift by a day. And at that point, I would say if you are looking at an extended forecast, let's just say, for example, a lot of these apps now go clear out to 10 days. A lot of TV stations go out 7 to 9 to 10 days. If you see a big jump or a big drop out there, just make sure you're clicking on it again in a day. Watch that extreme and see how it shifts over time, because chances are it won't disappear. We just got to figure out a better time frame for it. So I think presence of extremes or significant dips in temperature especially are going to be something that could change forecasts quickly.
Yeah. I think, to your point there about like looking far ahead, a lot of times you'll see maybe a substantial adjustment in a forecast, especially when you have a big system that is at the forefront. Maybe roughly like 4 or 5 days out, and maybe again roughly 2 or 3 days out. That just kind of like, whoa, what happened? I thought it was going to rain and now it's not, or something like that. And honestly, one of the big things that's happening there and why the forecast is changing is we're getting new data in. The closer to an event you get, the better information we have. And a lot of these storms, well, yes, modeling is able to indicate, and we're able to look at waves and stuff and patterns that are happening, and know that a system is moving toward us, or going to impact maybe the United States, but we don't know exactly, northern, southern, like where exactly. The closer it gets, the better data we have, and the more we can kind of narrow down um, into what is actually going to be influencing the weather in a particular spot. So things like, a lot of times the storms, by the time they get onto your 7 day or your 10 day or whatever, number of days you're looking out, sometimes they're still over Asia or Russia or something like that, right? They're not they're nowhere near us in the United States. Or if you're listening from another part of the world, basically half a world away, right? And so the closer you get in timing, the better indication we have, more data. And so that's why you might see the forecast kind of quickly pivot, is as something is getting into an area that has more buoy data or more satellite data or more radar data, whatever it is, that you're able to get a better read on what that storm is, what it's capable of, what's driving it, or what it's going to be influenced by. And those minute changes farther and farther out in time will start to have a bigger impact. Basically one tiny change here will have ripple effects down.
Well, you're right. You're right. And the other part about this too is when you just mentioned Asia and Russia, there's a big old body of water between us and them. And there's a whole lot of no data out there. Now, some of our modeling, a lot of the modeling actually can help, initialize through a satellite feed, which is great. That's helpful. But you still don't have a really good chance to evaluate that until you get some measured data. The other part about this, and the data is fully transparent. It's fully transparent. The Weather Prediction Center has this. We watched absolute forecast error decrease for over a generation until shortly after 2020. And there was a point there where your 3-day forecast back in the 1980s was as accurate as our 7-day is now. So it's huge how much is expanded with
We've
all this.
made intense gains.
Yeah, huge gains. Well, now we're seeing things go in reverse a little bit. It's not a lot, but compared to where we were, it's a little bit. And I can liken that with, let's say you go to a restaurant and you've been going there for many years, and it's always just been getting better and better and better. And then all of a sudden new ownership comes in, and it's still good, but it's just not quite the same. And here's what I'm getting at. We used to, like clockwork, launch weather balloons twice a day at all locations everywhere. Now we just hodgepodge it. Whatever. Launch when you can. So all these models that we're used to,
if you have the funding, great. Yep.
Yeah. All these models that were used to consistent data, and then the scientists that help run the models can utilize that data and realize, all right, the bias is a little bit here. Let's correct that. We were getting down sometimes to a day 7 forecast having less than a 3-degree error in it as we approach 2020.
Think about that. We're predicting the future. We're predicting the future a week in advance within 3 degrees.
You're within 3 degrees. And that was in the central region. Not even to mention the southern region. So like COVID hits, it derails.
And what Kai means by that is that notoriously the central region forecasts are more varied than a lot of the rest of the U.S. The rest of the U.S. is even closer than that 3-degree mark.
Right. And that's where we were at our best. And now we're not there. And a couple reasons, we used to get a lot of airline data. We still do. But when 2020 hit, the airlines were not flying as much. So that was a big hit. You could actually see the performance go down. And then now we're just screwing around with balloons. And so these models have been used to getting new data at every 12 hours. And now some spots won't give it to them at all. Others are, they're getting new data in some spots every 6 hours. It's like, I don't quite get that. But I think that's another thing that can cause some of this to happen. So with that said about, the weather balloon situation and the little data rant I just went on there, let's get on to the next question here, which is equally puzzling. And this actually happened to my daughter and I while we were driving a little while ago. Would have been last week. How does it rain when there are no clouds overhead? Like, what the heck's up with that? That's another question that we received.
Yeah, there's a couple different things. Sometimes you might be looking at a sky and, there's no cloud immediately overhead, but there are some clouds in the sky. And a lot of times what's going on is it's probably maybe higher level winds are stronger and maybe blowing precipitation over your area where you are on the ground, even though there's not a cloud overhead. So that's maybe one of the most likely reasons. However, it does happen sometimes where you get what some people call it a sun shower. And there's literally like, it doesn't look like any clouds in the sky when it's raining. And that can happen basically where the cloud essentially evaporates before the rain reaches you. So it looks, by the time you're paying attention to it, it looks like it's raining out of thin air. But there was a cloud probably, because rain has to come from clouds in the first place. No matter what, you have to get precipitation. You cannot just get magical precipitation. It does not happen. So even if you're seeing it rain, it doesn't look like there's a cloud. Maybe that it's coming from. It did originate from a cloud at some point, at some time. Maybe the cloud evaporated. Maybe that cloud is just further away from you than you think it should be, and you don't realize how strong those winds are overhead. Those are probably the two most likely reasons. Do you have any other reasons, Guy?
Not immediately that I was thinking of right there. I think that's all good. Yeah, the whole thing about the cloud just kind of giving themselves up and dropping rain is pretty funny, actually, when you think about it.
Yeah.
But it does happen.
Yeah.
And I think that would be about the extent of it. Yeah, the other part would be, maybe there's not a cloud directly overhead, but it's very close to you. Mm-hmm. And sometimes, what's interesting is the way the atmosphere is working and the way light is bending. You might be right on the edge of a cloud. And so therefore you might still get that shower. But no, that's all good stuff. And the best part is when it's happening and the sunshine is out and shining. And that's just an angle of the sun situation at that point. The light can still shine in as the cloud and the rain is above you. But that usually means the shower is pretty darn small, if that's what's
for sure
going to be happening. It's not like
anytime you have something like that happen, it's almost always a very, very light little sprinkly shower that, very brief in nature, and everybody kind of perks up and they're like, "Oh, what's happening?" And then it's done in another minute.
Right.
It almost never lasts that long.
It's enough to ruin a garage sale. That's about it. I've seen it happen multiple times.
Yeah. Well, let's move into our trivia question for today. We're going to talk a little bit about boundaries. So today's question, multiple choice. And that question is, a boundary between an air mass is called, is it A, a front, B, an inversion, or C, a cyclone? Again, that question, a boundary between air masses is called a blank. Front, inversion, or cyclone? Kyle will be back with the answer here in just a minute.
All right, 3 possible options. Front, inversion, cyclone. So think about it, and I bet you came up with front. If you did, front is correct. And in its very simple sense, a cold front is the leading edge of colder weather, and a warm front is the leading edge of warmer weather. And there are 2 other fronts, even though this is not going to be a front seminar. Stationary, which is one that doesn't move much at all. And then another one is called occluded, where the entire thing is kind of caught up with itself. And it swirls around a low pressure system and kind of catches up. So basically the cold air caught the warm air before the actual front was coming through. That's how that works. So if you guessed A, you are correct. Now we move on to some severe weather topics here. And this question came from a school visit. Jan, the fundamental differences between a tornado and a hurricane. They both swirl, they both do damage, but there are fundamental differences. What are they?
I love this question because kids do ask this one a lot. And it is when you think about it meteorologically, like there are huge differences, but there are also a surprising amount of similarities as well when you really start to think about it. But let's start off with the big differences because I think that's what the question really is, and the most important part here. So hurricanes, we all know they happen in the tropical areas. They tend to form over very warm ocean waters, and then move into those coastal areas and do a lot of damage. And they can actually have tornadoes with them. Tornadoes, then, those often happen for us in the U.S. in what we call Tornado Alley or the Great Plains area. And those are going to be forming more over land. There's obviously there's a couple different types of tornadoes. We won't get into all of that here, but you can have something called a land spout. You can have something called a water spout, where again different kind of flavors of tornadoes, we'll say. But overall, those tornadoes are part of a low pressure system, but they're a very small part. Whereas a hurricane, on the other hand, literally is the low pressure system. So scale wise, a hurricane is much larger, covers much more area, and because of that has a wider impact. I'm not going to say a larger impact, but a wider impact. A tornado, though, then those, again, much smaller, generally more intense in terms of higher wind speeds, but more localized. So a much more condensed area that it is impacting, maybe though a little bit on the stronger side of that impact because of it. So again, we're really comparing apples and oranges here when it comes down to it. So many people, because they're spinny wind things, people like to compare them, but it really truly is very, very difficult to compare them. When it comes to, again, how they're forming, how all of that is happening, hurricanes, again, those are forming in very warm ocean waters, typically 85 degrees, and they you have okay, I'm going to compare them again, even though I just said you couldn't compare them, right?
Go for it.
Both hurricanes and tornadoes need very specific amount of ingredients, right? You need specific temperatures and so we talked about our warm ocean water for tornadoes. Again, your land surface temperatures, but you also need the moisture. You need the wind, and both of these systems. This is where I'm going to compare them. Wind does have to be very specific. You can't have too high of wind, which feels very counterintuitive to strong systems, because the too strong of wind will literally rip the storms apart. And so that is one thing that as meteorologists we do compare them in that sense, because you cannot have winds or driving forces in that storm higher up in the atmosphere that are too strong, because then the storm is not able to sustain itself. So yeah, very long roundabout way, but essentially, again, your hurricane, bigger, tropical, forms over water, and then your tornado is going to be that smaller scale, but still very high intensity storm that is forming based off of, again, similar ingredients combining, but in a different way. It's the same way you might make chocolate cake and chocolate brownies out of the same ingredients, but because they have different amounts of them, or you're baking them in a different way, they come out a little bit different.
Yep, I love that. I was just gonna go back to my restaurant analogy, but you were fine on the food, so I'm good. I'm absolutely good with that. Yeah, they're just, And when tornadoes happen within hurricanes,
Yeah.
they're still different too. They're still different forces. They're still different sources of energy to do that. And a lot of times when
They're
they happen
more,
within a hurricane, it's tough to discern them, you know.
yeah, they're more of that kind of like spin up variety. We in the Midwest we have tornadoes that may form along an edge of storms that are kind of embedded within the storm. That would be maybe the more comparable way to compare them versus that like lone supercell storm that is its own entity. That's not what you're getting. You're not getting that style of tornado within a hurricane.
Right. No, not even close. Not even close. You're not going to see, EF4s come out of a hurricane. You might get really strong wind, but it's not going to be to that level out of anything that's going to come out of a tornado that is spawned by a hurricane. All right. So cycling back here to the very first part of this episode about forecasts changing so quickly sometimes. I'm going to just get up on a little box here, and we're just going to discuss this a little bit. Some of this comes into forecaster confidence when forecasts change so quickly. And then the other part is how precise do we really need to be? Because when we were in television, Jan, we would have consultants come in and they would tell us the latest research on what people want. And I remember when the hourly forecast was a really big deal. And that was started, about 2013, 2014 is when we really started to incorporate that a lot into our products. And then it seems like there's a more and more and more situation. And at what point do you start offering so much that it becomes lower confidence? And a great example is, let's say all the pieces of data are converging on a chance for some storms in the afternoon and evening. When you and I were growing up, that forecast could still work today. Dry in the morning. The later we go in the afternoon, the better our chances for storms. I remember Denny Frary was the chief meteorologist in my market, and that's exactly how he would speak. And that's exactly how we would plan. We would say, all right, we knew that this is probably going to be a late day deal. We didn't expect anything in the morning. And we also knew that stuff might not form because of the way he would phrase it. The better our chances will be, is what he would say. And so now, fast forward 25 years, same atmospheric pattern, same storm, except we are approaching it at a level that might even be just a little too confident. A chance of storms mainly between 4 and 6. That's a really tight window for a storm that hasn't formed yet. And do you tell that person who's doing a family gathering that night at 7 and a bonfire that all of a sudden you're good? What if you get rained on?
I don't.
No. What if you get rained on? Well, way back in the day, we'd still do that bonfire. We just hope that it wasn't us that got rain. But now if you pin it in 2 hours, and yes, the technology to do this has improved, but the atmosphere has not changed that much in 25 years. It really hasn't. And the physics behind it have changed zero. So are we being too precise? And a great analogy here is to lead this into, just watch ESPN anytime. Now that we're getting into football season, I think X, Y, and Z is going to be over 300 yards passing, 2 touchdowns. Great. You notice that even that could be kind of, pinning things in a bit, for fantasy football stuff. But then why don't you add on this? They're going to have 23 completions. They're going to have 1 interception, and they're going to rush it for 17 yards. You know why you don't hear about that? Because nobody freaking knows. And there's no reason to. I always, when I would coach people, I'd say, you're pinning yourself in too tight. How many fail points are there in that forecast? Now, you don't want to be the guy that says, well, the sun's going to come up, it's going to get warm, and the sun's going to come down. You don't want to do that. But you also, are all these accessories needed? Like, I'm genuinely curious from the audience. Like, are all these extras that we're seeing in forecasts really necessary, or are they just fail points? I mean, what do you think, Jan? You're out of the business now too. What do you think
Yeah.
about that?
Well, and as you're talking about this, I think it's very interesting because with the rise of the weather app and the hourly forecast, that does seem to be what people expect now. And it's kind of a chicken or the egg thing where I don't know if it's did that come first and we made them expect it, or did they expect it and so then we started feeding into that and now it's reciprocal and that it's still expected, right? That part I don't know. But it does seem to be something that has come of the expectation of point forecasts and people wanting to know exactly, when will it hit my house, right? When's the rain going to hit my bonfire? And so I don't know if we have the answers truly to that question, but it very much is an interesting thing to think about and to understand. And, I guess the reason we're mentioning this here on the podcast is for those listening as a consumer of weather, as, a listener, as a viewer, to just understand the constraints of the science. Again, the science continues to advance, but there are still constraints. We are still at its core predicting the future. And so understanding that 4 to 6 forecast window, maybe that is something that a consultant is saying, or that a news director is saying, like, you have to pin it down, but that the meteorologist is, that's the best bet they can give. But the science is still telling us, well, there's still a smaller chance, in that 2 to 7 or 2 to 8 window, right? Like going on the bookends, they're just kind of narrowing it down as best they can. So it's a different way to communicate that same stuff that, Kai mentioned Denny communicating earlier, but instead of having that chances increasing or as you go through the day, it's really narrowing it down, sometimes for the better, sometimes for the worse.
I'm going to close our podcast, Jan, on a word that you just said, communicating, because I heard it again this week. Folks will say, 30 years ago, they were better than what you guys were. Well, from a skill level, probably not. From a communication level, maybe so. And at the end of the day, it's communicating that stuff and recognizing the pattern and realizing that they didn't have electronics back then. And you did have to do the hard studying. And there were some incredibly knowledgeable people in this business 30 years ago that didn't have any of the excess stuff, but they knew how to communicate it to their customers. And that was the biggest, most important thing. And that's probably why they had so much success in what they did. So
absolutely,
we're going to leave you on that. Communication is key in all the sciences that you work in, but really every job that you have to be able to communicate what you're doing to your customer. So that brings us to the end of another great Weathered Questions episode. Again, if you learned something new, if this spurred a new topic, or you just want to do a follow-up, just let us know. weatheredquestions@gmail.com is the email to send us your thoughts. We also appreciate that you're telling your friends and family about this, because we continue to get downloads from places where I don't know anybody, which means that clearly y'all are telling people about it. So we really appreciate that. Don't forget to follow us. Don't forget to subscribe either. Until next week, stay safe.